Another rational function. Let's see how far we can go in just using our basic algebra instead of all our tools of calculus. So building sine graph, well, can I take that back? Before I build a sine graph, I might have a factor. Now, with this rational function, let's clearly sketch the graph, identify locations of intercepts and asymptotes. Let's identify x-coordinates of local extrema, and let's not worry about concavity. So building a sine graph, I will plot the zeros of my numerator and denominator. I now know when I live above and below the x-axis. So again, without any tools of calculus yet, graphically speaking, looks to me like I have two x-intercepts when x is 2 and when x is -1. I have a vertical asymptote at x equals -2. And I have a y-intercept at 0, -1. Now, because the degree of the polynomial upstairs is exactly 1 more than the degree of the polynomial downstairs, I have an oblique asymptote, and I can find it by performing some polynomial log division. If you don't mind, I'll use synthetic division as a shortcut. And so I have an oblique asymptote located on the line y equals, is that an x minus 3? Next on my list, so I think I found the intercepts, the asymptotes. Now let me dive into finding out when I'm concave. Sorry, because it's concave. Can I take all that back? I located the asymptotes and the intercepts. I do want to find out when I'm increasing and decreasing, but I do think before I even do that, the sine graph tells me a lot of information. To the left of this vertical asymptote, my y values are all negative, but I have to hug both the vertical and this oblique asymptote. So I know, graphically speaking, I behave as such. So I'm expecting to find a local max roughly around there. Now, in between this vertical asymptote and that x-intercept, and that's its coordinates, I see that my y values are all positive. So I have to be positive with my y values, but I also have to be hugging that vertical asymptote from the right-hand side. Now, between this x-intercept and that x-intercept, my y values are all negative, but I have to pass through that y-intercept. Now, with the way I'm drawing my picture, it kind of looks like I locally min out, again, on the y-axis. That may not be true, but I'll find out when I differentiate. Now, as I come back up, I'm going to pass through the x-intercept 2, 0, and I'm going to start hugging that oblique asymptote. So I'm going to identify the x-coordinate, this local max, and this local min, just to clean up my graph, give it more clarity. So allow me to differentiate. And allow me to build a sine graph for the derivative function. Here are my two critical numbers. Oh, there's a third one that I missed downstairs. Now, it looks to me like my sine graph is going to behave as such. So it looks to me like I changed from increasing to decreasing, then decreasing changed to increasing. And let's see what that means in terms of my picture. So apparently at x equals -4, I've got a local max. And so I guess this point right here has an x coordinate of -4. To find the corresponding y value, plug it into that relationship. Now, in between that local max's vertical asymptote, I'm decreasing. On the other side, I'm missing something, aren't I? Oh, there, so x equals -2, sorry. So between this local max and the vertical asymptote, I'm decreasing, but I'm also decreasing immediately on the right-hand side of the vertical asymptote. And change from decreasing to increasing at x equals 0, and I just got lucky. I did not know I was going to locally min out the y-axis. That's why I was saying I was going to clarify my picture, but I got lucky. And I do locally min out at x equals 0. And so I guess I can stipulate that x equals 0 is my local min, but I've already got that labeled as a y-intercept, so I'll leave it as such. From there on after, I'm increasing, and I'm hugging that oblique asymptote. Nice.